Is what? Okay. I wanted to start the official part of the Pykonik meetings. I wanted to welcome everyone on our 64th nice round number Pykonik Tech Talks meetings. Of course, it's not a 64th Pykonik meeting. It's just the 64th of the Tech Talks series, which is the longest and the biggest and most well-known of Pykonics. My name is Jakub and I will be your host today, although there are more organizers. Part of the organizers of today's meetings are sitting behind the console, doing the streaming to all our online viewers, which I wanted to welcome as well. And there are organizers scattered around the room as well. You can raise your hand if you help in the organizing of the event. Yeah, and the other one there is doing a lightning talk, but you can guess who that is if he's doing lightning talks. Nevertheless, I wanted to say a few words about the meeting today and about the agenda. We start in a quite unusual way because Oleg would give a presentation that will be divided in half. That would be around the magic methods and import system. And it will be, so the snack break would be sort of in the middle of the presentation, but always arranged in a way that we wouldn't just interrupt the presentation once the pizza arrives. We'll have a break for snacks and a bit of a networking, and then we'll get back to the second part of Oleg's presentation. After that, we'll have a shorter break, quick one to refill the things from the fridge and the stuff like that. And Dominik, who is right there, still doing more lightning talks, will do a series of lightning talks this time. And because we want to have more lightning talks on the meeting today, that would be a starting point. But of course, there will be an open space for lightning talks. And just a reminder, lightning talks is this part of the meeting where everyone can stand here on my place, bring a laptop or not bring the laptop, and just tell about anything interesting, anything new, any other event that he or she is creating or heard about. It's your space to take a microphone for up to 5 minutes. Do we have anyone who is interested in giving a lightning talk today? 1, 2, at least 2 people. Okay. You will have about 2 hours until they happen. So it is quite an often scenario that there will be more in the end. So after the lightning talks, there will be a competition summary. And I will tell about the competition in a minute. And then we're going to, for an after party, we're going to discuss a bit more about Python related and not only Python related stuff. Probably we will be heading to Infusia near Politechnica, which is like 5 to 10 minutes walk from here. Again, a question, who is interested in going for an after party? That's quite good, like nearly 50%, that's very good, I would say. I have a thing that on all of the meetings I ask this question so long that in the end the amount of hands raised raises by at least 50%. So we will see. There are a few thank yous that I wanted to say. The first thank you goes to our venue, our sponsor, SpotOn. Thanks to them, we are meeting here in this lovely place, and there are drinks in the fridge that you can grab anytime you want. And there will be a pizza break. Spoiler for a snack break. Yes, that will be pizza as usual. So there will be pizza in an hour. So let's give an round of applause to SpotOn. And 2 other sponsors that I wanted to thank. Thanks. First one, JetBrains. As usual, there will be 2 one-year professional JetBrains licenses to give away. Of course, that includes PyCharm, for example. What to do to get the prize from the competition? Just write about anything interesting that you've learned on, do we have that channel on the Discord? On the Pykonik 64 channel on Discord that will be created in a second. And I will tell about Discord in a second as well. Nevertheless, all the rules will be posted on Pykonik 64 channel on our Pykonik Discord server. Write about anything interesting that you've learned during the previous month. The answer with the most reactions wins the PyCharm license. So it's something to encourage you to just share some knowledge. And one last thank you for today. I wanted to thanks to our partner, Klug, Krakow's Linux user group. And thanks to them, we have all those lovely cables streaming, and we're online on YouTube right now. So let's give a round of applause to the rest of the sponsors. So about the Discord, if you enter discord.pykonik.org, I will keep that slide live for a minute, but it's easy to remember. If you enter discord.pykonik.org, it will redirect you with an invitation to our Discord server, and there just take a look at the Pykonik 64 channel. I wanted to highlight one thing, that the competition will be resolved only for the people who are here in the room. It's not for the people who are on the streaming or watching us on YouTube. But of course, you can always share something interesting, whether you're interested in a PyCharm license or not. And I encourage to join our server, because all of the information related to Pykonik meetings and some other Python-related stuff, local or not, are happening on this Discord channel. And that's it from my side. I will be passing the microphone to Oleg so that we can start with the first presentation. Probably it will take a minute to switch the laptop, but we can already welcome him with a loud applause.
Okay. My name is Oleg. I will talk today about import system and magic methods in Python. About me, I'm participating in different programming hackathons. For example, one of the hackathon I participated of was what the hack, what the fuck, and we made a special app which fakes run activities. So you can, for example, lie on the chair, and basically it will fake the run activity in your social media that you run for few kilometers or something like that. Or for example, we made a special app which tracks a car plate. And then if driver make some bad moves on the road, you can assign a deer label on him, and then on the road during in the traffic, you can understand how many deers you have around you. So this is basically some examples of project for fun. It's not for some business use or something. And today, I will talk in this kind of concept. I will show you some interesting tricks around Python import system which you can use, but probably not in production. But I hope you will learn something along the way, and maybe it will inspire you for do something more and maybe even production ready. Let's start from the problem. Let's say we have two apps, very basic and generic apps with models and controllers and stuff. And now we have this kind of situation when in the second app, controller.py, we make a call. We basically make an import of the models from this first app. We import database object, and then we directly update data, maybe related to that first app or something like that. So this is clearly a problem, because you break the scope of the first app and you mess around a lot of different things and parts, because you shouldn't be able to update objects in a different app. Directly in the database. So this is how it looks like on schema. So controller is more like high-level model, and you're making a direct call to the database object of the models, which is kind of internal, like core part of the first application. This kind of problem, I would say, defined in clear architecture, that you need to have a good scope of different parts of your system. You need to have like layered application and like move from layer to layer and not breaking any scope along the way. So we want to block this kind of calls because sometimes it's really painful in a very big monolith or something like that, because after some time your monolith become a very big mess, like it called a big ball of mud. And it's nice to have some tool or something to prevent such behavior. So the most like trivial idea what can like be implemented in this case is to move all internals to something like _private directory. So basically in Python, everywhere in code we use underscore to show that this is something like private. You shouldn't use this outside of some context. So if you move everything what like internals of the app under this _private package, it will become more obvious that something wrong is going on. For example, in this case, when you read the first line, like from app one, like _private, you already see that something like it's like a very clear alarm that something is wrong. Yeah, but the problem here that you still able to call database object, you're still able to update object in the first app, and we don't want to do that. We want to block that completely. How we can do that? By hands, without special linters, because there are some linters which can basically analyze your code and help you to detect such things, but we want to do that by ourselves. The answer is basically to better control your imports and understand how everything works under the hood. And if we look to the Python documentation, we can find basically two like parts which are important for us because we can start from them. So the first part says that the import process checks for something in SUS models, and if it finds the model there, it tries to like basically import this model. It's some sort of a cache, and each time, for example, when model imported to your system, it will be there. And the second part is when Python can't find any models in SUS models, and then Python trying to start special like import protocols, which can be divided also on two parts, like finders and loaders. Let's check what we have here. So basically, it's important to mention about hooks, which Python provides for you to have better like extendability of the import process and help you to extend it, customize it as you want. So first thing called meta hooks, which is called in which is called at the start of the import process, and the second is import pass hooks. So how it looks like. So if you import SUS library and then try to look at SUS.metapass, you will find multiple objects there. For example, built-in importer, frozen importer, pass finder, and some 6 metapass importer. So this is basically some sort of finders which located in metapass, which is basically used by meta hooks. And each of these class will be called in order, and we'll try to import model based on the path you specify when you do, for example, from something something import something. If model not found like by any of these finders classes, import error will be raised, and like then it's up to you how to handle it. So the first one, built-in importer is quite trivial. Basically, it tries to import built-in stuff. Second one is a frozen importer, which tries to import precompiled parts. And then probably the most like one of the most important is like pathfinder, which tries to find the model by path you specified during like import process, and all of them has a special method called find spec. This method find spec allows you to define some rules by which a model will be imported to your system. Let's try to implement one of these finder class. So what we want to do here, so we want to make something like we saw in MetaPath. We saw there are 4 different classes, and we want to make our own. We also saw that like previous classes had a find spec method. So we basically want to do the same, and we can provide arguments based on the abstract class called MetaPathFinder. And then what we want to do is to print on screen basically everything what we will have inside find spec. So if we try to add our class to the MetaPath and then import model math, we will have a clear result. We will not have anything in our terminal. Why? Okay, so the idea here is that we added our like finder, class finder, in the end of the MetaPath. And when import system tries to import models, he will it will find a mass probably in the first one in built-in importer, and then basically imports this model, and then the import system will stop. So we will never reach my pathfinder because it will stop like in the first iterations. So to fix that, we need to add our finder in the beginning of MetaPath, so it will be executed in the beginning. And then if we run the script, we will see something like math, the none. So basically we see full name, the mass of the model, then pass it's none, and target also none. Let's say we have this kind of project, this kind of structure, basically the same like we had in the beginning, with 2 application controllers and models. And we have something like that when we try basically to import the first application from the second one. If we try to import controllers of the second application and use our script which we did before, like basically print all calls to find spec, we will see this kind of picture where Python basically tries to import test folder, then test folder up to, then test folder up to controllers, and so on. So solution for our problem is actually trivial. We can check if _private is in full name in that path, and if it's in full name of the path which we trying to import, then we can raise some exception. For example, it's not allowed to import underscore private. If we try to execute that script, we will get an exception, and basically it will be clear that we are not allowed to do something like that. But it's not the end, because some libraries, for example, could also use underscore private inside for some reasons. And if you just block by underscore private, you will also block all libraries in your project. So you shouldn't do that. So to fix that, we want to check if underscore private is only in our project path, not in the like libraries path or something like that. That can be done in this way. So basically we get the current path and check if current path is part of the path we want to import. Another problem is that we completely block the import of underscore private. So if you try to import underscore private from the second app, and it seems like legitimate use, it will also raise an exception because, well, we don't know anything about like our context inside our importer. To fix that, we can use inspect model. So if we will iterate each stack which inspect model provide, and check if the current path is inside the current stack. If it's inside, then we can allow the import of underscore private. If it's not, then we should block it. Yeah. So in this case, we basically iterate all stacks, then we get the model of each stack, and then if the path is if the path of the current model is the same like something before in the context, then we allow import. So basically, this thing allows you to prevent such cases which I described in the beginning. So you will not be able to import underscore private between applications, and you can only work in the scope of one application after that. What if you want to like now we can update models through controllers? It also like this kind of behavior were very well defined in Python then, that you should have only one obvious way to do that. And in our case, it will be only through controllers. You can do this through some core part of the application. And the whole workflow looks like that. So basically, controller will call another controller, which calls underscore private, which then calls something in models.py. So now we kind of jump between different models, but it's for better. So let's try to see what we can do with find spec, because for now we only validate things. We are not returning any specification of the model. We basically check if some pass inside the import pass, but we say that like basically this model not found, and then allow standard Python import system to search for this model. But like how we can do that? Like what is import specification? So if you check some model, you will see there is a underscore spec underscore attribute. And if you look inside, you will see a lot of different information. For example, the name of the model, the loader, which probably the most important one, the region, basically where it's located, and a lot of different other parts. If you check same thing for our project, which we did before, you will see a lot of like a lot more information. Basically, now we have another loader which says source file loader, and also we have a cached attribute, which basically a link to the PySif file, which precompiled one. So yeah, like this spec, each model have a spec, and this spec defines basically a strategy of how the model will be imported in our system. So let's try to implement something which will return some sort of specification of the model. Let's say we have some model called model to have fun with, and if we're trying to import it, we will return as some very dumb object. We basically contain two parts, like full name and our class, which basically do nothing. In this case, we will get an error that we don't have attribute load model. It's a special attribute which like each loader should have, but we don't have it in this class. So if we check documentation, it will say that load model also deprecated. So it's kind of saying that we don't have it, but it's also deprecated. So now a proper way to do that is to implement create model and access model. If you look inside source file loader, which basically a loader for our project, you will see how it's implemented inside Python. So create model is basically nothing, and if it's nothing, it will use a standard Python import behavior, basically logic, and access model tries to get the code, which sometimes can be also precompiled one, and then simply call access code and then model __ dict. So it's very short and quite simple. To speed up our presentation a little bit, we don't want to make model spec by hands because it's a lot of different corner cases and parts to consider. So we want probably to use something like spec from file location. It's a helper in import lib library, which allows you basically to define the specification by some path of the file in your file system. So this is how it looks like. So if we're trying to import model to have fun with, and yeah, we basically make a path where it's located, and then we use a special helper which define a name, location, and loader. Also, in that case, we inherited our custom loader from standard loader, and if we execute everything, we will get something what located in that model. So basically, we imported this model by our hands by passing the standard finders which we had in MetaPath. So now we can extend this part and do something interesting. For example, we can try to implement our own loader and add create model and access model methods and control how a model is initiated and executed. So for example, instead of actually executing the model, we can add attribute, some random attribute to that model, and then assign some random string. So now, even if model to have fun with defines some attributes, say hello, it will be overwritten by our definition here, and it doesn't matter what is inside that model. So basically, during the import process, we redefine some attributes of the model in the way we want. So when we basically know how to make these special finders and loaders, and how to properly initiate them and how they are executed, we can control the import system, and yeah, and try to extend it somehow or customize it. So, for example, probably someone who like doing a lot of data science work or something like that, tired of doing this, basically constantly open files, like loading some data in your model, then like basically define some variables. You need to have a name for your variable and stuff like that. So what if these lines we can replace? Yeah, basically this is how it looks like, the structure. So we have a data JSON, a JSON file, which is basically a text file, and we can replace this with statement with a simple import statement. So now instead of opening the file, we can simply import a JSON text file inside the Python, and it will be a valid model which we can work with. So as you can see, before we had a JSON text file with key say hello, and when we imported it, we can basically print that key, and it says hello from JSON file. So how to do that? How we can extend our finders and loaders to do something like that? So basically, we need to define a find spec to make sure we are able to find that file, like text file, and properly load it. So our finder will have two parts. The first part, which is like if.json in full name, will import a JSON text file like a model. And the second part will import everything before .json like a package. So, and if we don't, like if we didn't find any .json file in our system, we will return none, and for example, import error will be raised if file not exist in our system. So yeah, so basically the first part checks if JSON is part of the import definition which you have, and if it's there, we will make a specification of the model and call our own loader, which will like basically read a JSON file and initiate everything. Here our custom loader. So if we have a .json in model name, we're trying to load this basically with a standard library JSON, and we will put each key and value from the dict to the model, like basically to assign us an attribute. It's not very secure, so don't do that. Don't do this. But yeah, you can do this for fun or for educational purpose. Yeah, and in the end, we will have a model which basically have all attributes from the JSON text file like keys. So you map keys to the attribute of the model. Yeah, and you don't need to write 3 lines more, just one. So now we can do more stuff with our import system because we know how to control a lot of parts. For example, we can make something like Golang does. For example, we can import from github.com Django and import Django. So it will do very similar, like basically in the same way like Golang does. So it will clone Django repository locally to your file system. And when you do import Django, it will basically import a Django package, like a Django model. the first run will clone the repository, and the second run will just execute it. So yeah, this is basically the example how located in the file system. So how we can do that? It's actually quite trivial. So basically, if we have a github.com inside the full name, like inside our import path, and this full name has four parts like github.com, then organization or user and repo. Then we clone repository locally, basically initiate a git clone something somewhere. If we have a lib name in the end, basically we have 5 parts, then we can try to find that repository in our file system. And if it exists, we will load this repository using a standard Python import system, import module, and we'll return a spec. And if GitHub in full name in our import path, we need to return a package because it's probably just a part of the path which we are following to user and repository itself. So yeah, and here we have my loader, which is basically very dumb, and yeah, and then you can do something like that: github.com Django import Django, and yeah, one step closer to Golang. So here we can make a break, or yep.
Okay, so the pizza has arrived. It's right there in the kitchen. We'll make a break around half an hour. Remember about the pizza, the drinks in the fridge, and we'll be back in half an hour, I think. Okay, so thanks for the first part and enjoy the break. So I will ask you to slowly take back your places. Feel free to go to the front rows if you're not seeing or hearing well enough, because there's plenty of space in the front rows. But no pressure. If you want to sit at the back, feel free. So we're coming back with the second part of the presentation, and as sort of a small reminder, I wanted to remind that after the second part of presentations, we would have lightning talks. Dominik would have 2 to 3 lightning talks as a start of a good start of a lightning talk session. I know that we'll have 2 more. Anyone else would like to tell a lightning talk and haven't raised his? Yeah, okay, so we'll have 3 lightning talks for now. Maybe there will be more, we'll see. And there is still an ongoing competition on the Discord channel. Pykonik 64. Feel free to share anything interesting that you've learned during the last month to win a PyCharm license. And I also wanted to reminder that after all of that, we're going for an after party in the Fuzja. And who wants to go for the after party again? Everyone? Yeah, more or less the same. So I would keep trying. All right, and I'm giving the control over to Oleg once again, and let's hear the rest of the presentation.
Let's go. Dive into more complex part. Do you have any questions about previous part? So yeah, basically just to remind that in case of GitHub import, we check for full name and we check for github.com in full name. It's like import path when you make something like from github.com Django, and then we add location of our GitHub repository which cloned locally to syspath. You can also use pip install, so you can also like install Python library during the import process if you need to. And we don't have anything complex, like basically nothing in loader. So in the next part, what we want to do is to define a create model method. We didn't touch it before. So let's try to make a very simple finder, which basically imports everything in the path, in the full name path as a package. So now if you add this kind of finder to your path, you will always import something. You will never have import error because it will be basically a package all the time. And also we have create model method which return a magic mock. So magic mock is part of unit tests in Python. And now instead of returning a model, we return a magic mock. So if you try to use this kind of finder and this kind of loader, yeah, in case of a project or application like that, you will have this kind of situation. Let's say we have my project and we want to import some application, but this application is not a model anymore. Oh, okay. But this application is not a model anymore. Now it's a magic mock. So it's some object which you can, okay, works? Okay, so it's some object, we define some attributes, basically magic attributes like underscore get, underscore add, underscore mul, and get attribute, get other, and many other parts. So if you try to do something with that object, it will print you something like that, something like this. So in the first case, we have just a magic mock, a simple object. Then when we try to take controller from that model, we will have another magic mock with a pass to controller. If we try to do something with that controller, for example, call test function +1 multiply by 100, you will see the whole path of the execution. So basically you can see that we get attribute like test function, then we get attribute add to sum to values, and then underscore mul to multiply some values. So basically when you import magic mock instead of model, it can help you for tests. Basically you can wrap some parts of the system by magic mock and redefine some behavior, for example, for database to test some parts without using a real database, or for debugging purpose, because magic mock has a lot of nice useful things, for example, call args, and you can see what arguments someone used to call this model or some methods inside this model. But what interesting here is that we have a tree of calls. So each time we are making something with that magic mock, we always have like some sort of a chain of execution. And it's very, very well defined because we have add, multiply, and other parts. What we can do with that, and like how magic mock looks inside, because to do something with that, we need to understand how it works. So if we look to the source code, you will see something like that. We have set other in the end, which for each magic method defines magic proxy. This is basically a list of magic methods we redefined in magic mock. And here a very nice example of call class. So the call class is when you call the magic mock, it will return you another magic mock, and it will be basically an infinite loop, infinite chain of calls. And also it defines get utter, which in a similar way as underscore call return the same object over and over again. But what interesting in that object is that it defines name and parent. This is very useful information because you can use it to build some sort of a tree or understand the whole chain, the whole path of the execution. Basically by looking on the root, on the leaf of execution tree. So now we can try to make our own mock kind of object, basically to better control this process and just to demonstrate what we can do with this kind of stuff. We want to define get attribute, and each time when someone tries to get attribute of the object, we will return the same my mock object. And it will be again similar to magic mock. It will be like some sort of recursion. You try to get attribute, it returns a magic mock, and so on and so on. When you want to set attribute, it will in similar way return you like custom mock, our custom mock, and similar behavior defined in underscore call and underscore add methods. If we try to call and look inside this mock object, like our custom mock object, we will see a lot of interesting information because, for example, when we print just an object, we have like parent none, parent action none, like everything is none. If we try to get attribute A or method A, whatever what defined under A, we will have a parent action A and a parent object, which is also a mock. And when we try to do some arithmetic operations like +1, we will have a parent action underscore add, and the parent will be our like first custom instance of the mock. If we try to do some arithmetic operations. We will have something like that. It will look like a tree of different objects which have parent action and parent, and it looks like execution tree, which quite similar. Yeah, basically it looks like that, and it's quite similar to AST. So in Python we have abstract syntax tree, which allows you, which basically read a code and try to represent a set of different statements, rules, which then will be executed. This is how AST looks like. And on the left side, we have like a tree of execution based on our mock objects. The main difference between them is that AST is basically built before runtime, and our tree is built during runtime. The fact that it built during runtime allows us to control a lot more, because we have real objects, and we can control more. But basically what we have here is execution tree on both sides. Now we can dump this tree to JSON file, and statement like that, when we call get stats +1 + 100, will be written to the file to the JSON file with that kind of structure. And today we already worked with JSON files. So, and now what we can do is read this JSON file and recompile it back to the Python code. So step by step, we made the import which returns a magic mock. Then this magic mock allows you to make an execution tree, because each time it spam a new magic mock and have a link to the parent. So we made some sort of execution tree which we can encode to the JSON file. And now in another process, we can read that JSON file and try to execute what we have. Yeah, this is how it looks like. We don't have a finder here because it's very similar to what we had before, but we have loader, and inside like access model, we're trying to read that JSON file and parse it, and trying to restore the Python objects from that JSON file. The logic is well, quite trivial. We basically look to the parent, it's a recursion, we go inside, and then each time we go like out, we're trying to call it if we have __ call method in actions. And if it's not __ call, we return get other from that object. So yeah, so that parser will make this JSON file a Python object again, which we can execute. Yeah, so if we have one kind of model or process, whatever, we dump everything to the JSON file, and in another model or process, we can import JSON file like a model. We can redefine get stats as a magic mock and say that it will return values 3. And now if you call tree.json.run, it will show you a result of that expression in the beginning. Basically, get stats will return you to 3, 3 plus 1, 4, and it will be 104. So this way we can like, it works in a similar way like Pickle does, but it can be in some cases more useful than Pickle. So how it can be useful? Well, you can debug in production. I didn't try it in like practically, in the sense that I didn't have much time to implement something like that. But theoretically, you can import some model, then execute some method of that model. This model will be a magic mock, like our custom mock, whatever. Then when you call a new method, it will send a JSON file like a command to remote server. And remote server can execute this JSON file, which I showed you before, and return some result. The nice thing about all of this, that you can very easily control what you executing. For example, if you call a method destroy database, you can easily check on remote server what commands you are executing, and you can block such commands and such behavior. So this way we can execute something on remote server in kind of sandbox environment, limited way. But I didn't try it in practice yet. So this is just an example how it can be done, what I described in the previous slide. And here we have some sort of schema. We have some expression. We can encode this expression to JSON file, like an execution tree. Then restore Python objects. And then if we need to get some results from getStat, and these results can be only like calculated, for example, on remote server, we can send another JSON file like a tree to remote server to calculate that result and return a result back to our Python process. And we can then continue the execution, and all of that will happen inside the inside the import process. So basically, when you import the model and you say .run, it will start all of this magic. Yeah, it's complicated, but I recommend you to just play with it. Try to make this kind of mock object. You will see the execution tree like that. One sec. So you will see the execution tree like that, and then you can play with different like approaches, how you can restore this to the Python objects and how you can execute this. Yeah, this is probably everything what I would like to talk about today. Oh. Questions?
Do we have any questions? Anyone?
Nope.
Right. So I'm just checking.
I can have one. Like, can you think about any real life case where changing imports can actually be pretty useful in production?
Well, it's hard. For example, the first case when you can limit what would you like to import in different scopes, in different contexts, can be quite useful. But again, this modification to the import process is sometimes quite complicated, especially from security side, because I did a lot of dirty tricks there. For example, like adding something to the SUS pass or making pip install inside the import, assign attribute to the model. So if you in the second example with JSON file, if you assign something from the JSON file like directly to the model attributes, it's like super dangerous. Like you shouldn't do that at all. Yeah, so this kind of tricks, well, should be done very carefully, and yeah, and it's very hard to maintain. Basically, if you even found any case, practical case, then it's hard to maintain it during the time. Yeah.
Do we have anything online or any? Yeah, there's one more question, and you can maybe check online.
That's not really a question, more an addition to what you said about the well, as the answer to your question. It depends also on what you mean by production, because if you're for example making an application, what you can do is you can use the import hooks to import Python code from custom files, which will then be supplied by the user, for example. And this is something that I've done. You may remember that. So yeah, this is also a way to use it successfully, let's say.
Yeah, yeah. It depends also on use case.
Oh, this is literally the same way as Python does it with the zip file importer, by the way.
Yeah, yeah, and some libraries as well. For example, this 6.1 is for Python 2, Python 3 compatibilities, as far as I remember. So yeah, they just made another import for this kind of purpose.
Okay, do we have any other questions? If not, then thanks a lot, Oleg, for the presentation.
Thank you.
And I think that since we're a bit ahead of the schedule, we can just start with the first round of lightning talks by Dominik. You might be glad you'll have a bit more time. And of course, just after this round of lightning talks is finished, there will be another round of lightning talks. And probably we will make a 5 to 10 minute break before this happens. Worst case scenario, we'll go for an after party a bit earlier, which is not that a bad case scenario. Okay, so let's give Dominik 2 minutes to plug in. I think that it went pretty quick. Okay, so we're ready to start. So let's welcome Dominik with an applause.
Welcome. I'm Disconnect 3D, not 2D. And today I'm going to speak about 3 to 4 things. We'll talk about a case study of optimizing some command in PwnDebug, which I will also mention about. I want also to tell you about libcst and QR reception, and also there will be a PyCon PL 50% discount for the ticket, like a competition. Okay, so the first topic I want to speak about is this optimization case study. So for those who maybe didn't hear it already on like previous Pykonics, there is this plugin for GDB, which is native debugger debugger for native programs. This plugin is called PwnDebug. It's written in Python because you can script GDB in Python. And for those who never seen this, well, if you launch GDB and like you start debugging something, normally you see pretty no information, but if you have PwnDebug loaded and you start some program, like here we start bin.ls under a debugger, you will see plenty of information, which is even too long to show here. but this can be useful if you want to like debug assembly code or C or C++, or basically if you want to maybe learn how all this works as well. And you can see some of my environment variables here. Cool. So this case study comes from this issue that someone created in April, which is called faster vis, because there is this command called vis heap chunk, and vis is an alias for it. And so the guy used this vis command with some flag, and it lasted for it took like 15 to 20 minutes to process, basically. And also, for those who do not know, you can use GDB to debug plenty of things, like, first of all, different architectures. So it doesn't have to be x86, as I have here, like a computer on x86. You can use this also for like ARM architecture and many other architectures, and also on embedded devices. And this person was debugging an embedded device, which is kind of important here, but we'll get to it. So yeah, this vis is vis heap chunks, which stands for visualize heap chunks. So for those who do not know, there is this thing called heap memory, and this is basically dynamically allocated memory. And in glibc, which is the standard library for C, and for example, Python uses it. The way it works is that on the right side we have memory, on the top we have lower addresses, on the bottom we have higher addresses. There's some chunk of memory allocated for the heap itself, and whenever you are doing some kind of small allocations, like I want to allocate 16 bytes of memory, this will basically like allocate the 16 bytes by allocating it on this memory that's pre-allocated already. So we did not even make a call to the system itself to allocate memory. Like glibc allocated like a huge chunk of memory before that, and it basically manages this huge chunk of memory. And when we do small allocations, it will basically like take chunks from that part of memory. And then when you free some memory, like this pointer free that points to this chunk free, it will be marked as a freed allocation, so that whenever you allocate again, you can get this back. There are also plenty of different edge cases here. For example, if you try to free the first chunk that was allocated, it will be merged with the top chunk, so that the top chunk will be bigger. Maybe the top chunk should be like from the bottom to the top at start. I'm not sure. But there are also many other edge cases, like there are some kind of linked lists that keep track of those freed allocations and so on. So it's pretty complex, and it's made this way, first of all, to be fast in the most possible cases that people have, and second of all, to also allow people to debug their kind of broken programs when they do something wrong in terms of allocating memory or dealing with it. Anyway, so that was like, something as a context. So this vis heap chunks command, what it does is it visualizes stuff, right? So if we try to, for example, open Python 3 under GDB and we start Python 3, we are in the Python interpreter. Now we can stop it, get to the Pwn debug console or GDB console, and we can do this vis heap chunks command. And as you can see, this is like super colorful hex dump of those chunks in memory. And here you can see the contents of this memory. So, this is not very readable. There is no like cool data here, because apparently, for example, here is some string in NUS UTF-8. But lots of this may not be that readable because, there are some data structures stored there, pointers and other stuff, right? But basically what we do is that we display the address it's on, we display the contents as well. Actually, this is not exactly a hex dump. This is actually like 8-byte words here. And here is like a representation in ASCII of that memory. There is also a small catch that is hard to show on Python 3. But if we try maybe on binls and like break on exit, maybe we will be able to observe it. If we do visualize, we can also observe some kind of like arrows here that marks some kind of labels, because some of those chunks are in those like linked lists, in the allocator itself, and we are basically telling the user, hey, this chunk is in this linked list, and so on. We will not get into more details of how this heap work. So that was all I wanted to say about it. But coming back to the optimizing this stuff and measuring performance. So how do we do it in Python? Well, there is this Python profilers documentation, which says that you can use this cprofile module. And there is also profile module, which is written in Python, but it's slower. It's maybe more flexible, but you pretty much would end up with cprofile most of the time. There are also other profilers on the internet, but I'm just using cprofile. The simplest thing you can do with cprofile is just import it and run some code as a string. It will evaluate the string and measure its time, and it will give you something like this. And here we can see that in 0.002 seconds, it executed 214 function calls. And here we have some legend of the data that is shown below as a table. And there is also a legend for this table. I mean those labels. So for example, there is something like cumulative time, the cum time. This is the time spent in this and all sub functions, for example. And it also says that this is also accurate even for recursive functions. There is also tot time, which is the total time spent in the given function, and excluding time made in calls to sub-functions, which is probably very, very useful because maybe you want to measure this function, but not the function it calls. But maybe sometimes you want to measure also the function it calls, so you probably look at those two numbers. An interesting thing is also n calls, so this is the number of the calls, obviously. But in Pwn debug, we basically wrap this cprofile into some kind of profiler start and profiler stop functionality. And if we want to measure this heap chunks command, we can do something like this. We can have the first script written in Python, and then since it's GDB, we need to execute GDB, we need to load Pwn debug, and we need to execute this script under GDB, under some program that is debugged after we, pause the program in a specific moment of time when there is enough data to measure the performance. So on the bottom, we have a shell script that launches GDB. It will stop the program on the exit function, and it launches Python 3. It imports the sys module, and it will execute sysexit. Python will start. It will allocate plenty of memory. It will execute sysexit. This will execute the exit function, and GDB will stop Python at this point, and then our profiling script will execute. And it will create some kind of profile.prof file in the end that we can use to analyze this. Maybe I won't show how to running it itself, because it will take 10 seconds at least. Okay, so how do you optimize this function? Or maybe let's look at this function, and maybe I can first show it on GitHub in its optimized form. But even though this heap chunk, sorry, it's in heap.py, I believe. Yeah, so maybe those are small letters, but we start at 800 line, and it's a command that is provided as some kind of terminal from GDB. So we need to parse some arguments. We have plenty of arguments here. Then we parse them, blah blah blah. There's some while true loop that does some computation, and then there is some stuff about colors because people like colors. And then there is the most interesting part. So there is some kind of for loop which has a while loop, and in the end we are just printing all the output after we computed all this output. So if we simplify this would look like this. So as I said, we have some kind of loop over some chunk delims. Then we have another loop over until the cursor, so an address of a chunk, is at the stop address of this chunk. And first of all, we are reading some memory on the right side. We are unpacking it, and then we are creating some kind of hex string of this, and then coloring it, right? Because that's what we saw on the output. Then we also need to compute those labels that I showed you. And we also need to do the ASCII string, because on the right side we had this ASCII string column. At the end, of course, we need to increment the cursor somehow, because we want to stop this loop eventually. And we are going by just pointer size. That's why it's PTR size. Sure. So maybe some of you see some issues already here, but it's not so trivial. Yeah. So if we benchmark it this way, this is how it would work. We would run some benchmark script. So this is basically the script that launches GDB with those arguments. We'll wait like 14 seconds until it executes. And then we will get some kind of profile file, which we can process with another script that we have that will print out this interesting output for us. So as you can see, we executed like 38 million function calls, cool, in 14 seconds. And if we look closer, like if we analyze all this output here, we can see here that there are some functions that, were executed like, I don't know, 14 million times or maybe 1.5 million times, but they didn't really had a lot of time that we spent on it, like 1 second only in that out of 14. But for example, here is this function called bin labels that it took 7 seconds to spend in just this function over 76,000 calls. So this is like half of the time we spent in this function. Okay, so let's look at this bin labels. It was executed here, and this function looks like that. And its arguments are addresses, so some address and some collections. I didn't show it here, but those collections here, the bin collections, this is like a constant. I mean, it's computed once before those before those two loops, and then it's a constant here. The cursor is changing. The cursor is like changing by 8 every iteration, and yeah. So let's look at this function. It basically computes some list of labels, and it goes over those. And as I said, collections is constant, and address is used in those places. So we have some loop in a loop in a loop, and then if address is equals to some chunk address, then we will append a label. And we will return the labels for this. Because on a specific chunk, we may have multiple labels, which is probably a broken situation to be in. Like, it should probably never happen, I'm not sure. But it can happen. So we have this function here, and collections is constant. And we execute this function in a loop, because there was, well, actually in 2 loops, right? And we called it 76,000 times. It took 7 seconds, so like half of the time we spent. So the question is, can we like pre-compute all this function? Because the thing is that, okay, the address is changing here, but we actually know all the addresses that may happen. Because we probably know, since we are, iterating over something here, over some chunks, we know what's the first chunk, we know what's the last chunk, so we can, in theory, compute all those possible labels that could, in theory, happen. This set that we will get out of it will be bigger than the actual labels that are there, but maybe that's not a problem. And so, I made a pull request where I actually changed this bin labels function to bin labels mapping function. It now takes only the collections, and it pre-computes a dictionary where it puts the addresses as keys and lists as values for those keys. And then, we had to change the code that used that a bit so that we put that computation before the 2 loops, and then now we just use the map instead of the function itself. And this, this gave me like half of the time speed up on my setup, on my environment. So from 14 seconds, we went to 7 seconds. But this guy that created the issue, he also posted his profiling results. In his case, this was like 400 seconds to like process some kind of this command. And as we can see here, the total time spent in method read memory of gdb.inferior objects took like 80% of the time. The question is why, and the actual reason for this is that because he used an embedded device to debug on, and reading data from an embedded device during a debugging is pretty slow usually. So let's get back to our code. And the thing is, well, I'm showing you a diff here, but the thing is that we used this memory read function here with cursor and pointer size, and here as well with cursor and pointer size. And you know, in practice, why are we reading memory twice? The same memory. I mean, it does make no sense to do that. So, you know, that was pretty trivial to change. We just computed this memory once, saved it to data, and then used this data variable into places. And you know, that probably made a speed up for this guy of half time of this 380 seconds, which, you know, okay, it's around 200 seconds now for him, but it's still a speed up, right? And pretty good speed up. Okay, yet another optimization is from Czarna here, and she benchmarked like a commit after my changes, and in her case, we looked at the results, and you know, there was this. Now for the total time, the biggest spender here is this bin ASCII function. So the bin ASCII function looked like this on the top. It basically imported from string import printable. This is like a set of printable characters. String is a built-in module in Python. And it computed this list of valid characters, which are printable, removing some kind of characters that we were not interested in. And, you know, if we look back, this bin ASCII function was called 90,000 times here. So pretty much the same situation. We run this function over a loop, and, you know, it had it has to be executed in this loop because we need to compute this bin ASCII over new data each time. But the computation of the valid characters can be just removed out of this function, computed just once as a global variable, and just used here in this function. And by the way, maybe it can be even optimized more, like maybe with some mapping or something like this. I'm not sure. I haven't really tried. If someone wants to try, I invite you to, you know, benchmark it and send me a pull request. Yeah. And so this is benchmark before the commit, 4.6 seconds, and after it was 3 seconds. So, you know, like 30% of the speed up or something. I mean, it would still not be as huge speed up for the guy who spent most of the time in reading memory, but for all other users, it's nice. Okay, any questions to this part or comments? Cool. Another thing I wanted to show you is libcst, and which has this thing called code modes. So this libcst is some kind of library or maybe a research, I'm not sure. But this is a tool you install, and then you can use it over your Python code. And it can transform your code in different manners. Well, first of all, you can code your own code transformers, but it has many built-in ones. For example, to convert format to f-string, if you will use the .format function, you can convert it to f-string literals, or it can remove unused imports. I mean, your IDE can do that as well. But, you know, someone created this tool, and it's pretty interesting. And we had those two pull requests recently, yesterday. with using this basically to reformat our code base, because this code base is like 6 years old or probably more. And here are some examples. So for example, we use the .format function. It reformatted it to f-string literal. Another case, like a pretty long one, format function with like keyword arguments. It also handled it properly. The other reformatter was for the %string formatting. So cases like that were also fixed. Although not everywhere, because like here it wasn't. I'm not sure why, but maybe the tool missed that somehow. So the question is, why would you want something like this? So the thing is that if you actually like compute or measure the timing of doing a % formatting and f-string literals, it turns out that this is much faster than this one, and it's only nanoseconds, but if you do it like million of times, it matters. And the same goes for of course this kind of formatting. It's slower than the f-string literal formatting. So if you have an old code base which uses those old formats, maybe you want to improve it. Yeah, so that was why would you care about f-strings. Any questions or comments to this? That was my second lightning talk. Yeah?
Comment about f-strings, especially why they are faster, because there is a very important difference. F-strings are executed when interpreter approaches them, and the other two, like they are converted into the memory, like compiled into the Python binary, where other formats are being called with arguments. So there is a first of all, call is there is an overhead, but secondly, you cannot really use f-strings to like save them as a constant and save them for later to populate them with variables later. So that's the major differences why there is a performance bump.
Yeah, so yeah, f-string literals are more static. Okay. The last thing is QR inception, or maybe it should be QR reception. I don't remember. But thanks to Evan for showing me this. Yeah, it's QR inception. There was this paper in 2014 called Barcode in Barcode Attacks. And it was created by those researchers here, and it can be found on the internet on the link below. So what it shows is that there are different formats for displaying 2D images, and like encoding data into the images. Like you have quick response, which is QR codes. You have Aztec codes. You have some data matrix, or maybe code with non-square pixels, like some maxi code, Microsoft tag, and this PDF 417. And the thing is that you can kind of embed them into each other. And by the way, do you know where Aztec code is used? Do you know what is this? It's dowód rejestracyjny from your car. There is this Aztec code here. The problem is, if you try to decode it with Aztec, it will actually not work. And there was an article in 2018 from Zaufana Trzecia Strona about this. Because the thing is that, okay, it will decode with Aztec, but then it's encoded with some custom format further on. And someone probably took a lot of money for that, but, government. But going back to this research.
One question. Do you know where else Aztec codes are being used?
No.
That's a tricky question. Did you ever have to print your train ticket in Poland?
No.
No, okay, so you may not work, but Aztec codes are also used on the online podcast train tickets.
Okay. Yeah, but this research basically shows what happens if you try to like embed Aztec in QR and then try to decode it with different readers. As you can see here, there's like outer and inner, and maybe it's not super shown, but like I think here is maybe the Aztec code and here's the QR code, or the other way around, something like this. And you know, there can be a case of data matrix in QR, which if you look at the right side, it did not work well at all. But if they tried some other technique, it worked in 2 different readers. But you can also do QR in QR. And on the right side, you have like a big QR and you have a small QR on the bottom right of the image. And people did many funny things with that. Like there is this QR coder website where you can push, first of all, you can type in an URL, which the QR code will decode to, and you can send some image, and you can put this image into the QR. I mean, you can do that. It's pretty nice. And we have a competition for you here. So if you want to win a 50% discount for the PyCon PL ticket, we will have a QR code to scan for you. So prepare with your phone and decode the QR. Here's a test QR. This is not the competition yet. But yeah, you can prepare your phone and I will maybe give you like 30 seconds or something. Okay, I guess we can maybe start. So here's the competition. Obviously, this is a QR code in QR code, and you have to scan both of them. One of them is a link you have to go to, and there is a form you have to fill in, and you have to fill in the data from the other one. And you have to put your email address so that we can send you the discount for the ticket if you will be the first one to do that. So I'll give you some time. And by the way, if someone actually filled the form, they can maybe say, because we can then probably finish the competition. Nie da się? Co? Okay. A wypełniłeś formularz? Dobra. Okay, someone already filled in the form, so I'm sorry for the other people. And that's pretty much it from me. And here's some kind of recap from the stuff here. So first of all, we were speaking about the optimization case study for one of the commands for Pwn debug. And as you can see, there is some need for debugging or visualizing stuff in glibc sometimes. And you can use cprofile to profile your code. And also that environments matter. Like for some people, reading memory is very slow. And some performance improvements are trivial. Like, you know, we are all only people, and if we code something and it works, it doesn't really matter if it executes something twice, but it maybe start to matter if you are debugging a big program that has lots of memory. So, yeah. Then there's this libcst like library, which you can use to convert your string formatting stuff, and there is just QR inception or QRception research. Yeah, and that's pretty much it. Thank you. Or maybe any questions or comments about QR stuff or anything.
Any questions, comments? Anyone?
This heap chunk you mentioned. First of all, thank you for the presentation. It's amazing job. So this heap chunk you mentioned several times about glibc heap Just to clarify, it will visualize glibc heap, or will it visualize allocated memory pages? And if it's like glibc, will it work with any non-glibc?
No, it won't work with non-glibc stuff, and it will be very glibc specific. It supports different versions of glibc because people took effort to add this into account. I don't know if I can actually show you something. But basically, if you look over the heap memory page, it's like here, right? And if we go over this memory, there are like many zeros here because this is like the heap data that is not yet allocated. But if you do the this heap chunks, it will start printing you from the very first chunk that was, I mean, from the very last chunk that was allocated, actually, because the last chunk is on the top. Yeah, I mean, not necessarily the last allocation, but the last chunk was like allocated and expanded, right? Yeah, but we have multiple different commands. Like you can, for example, visualize the free lists for the allocator, and it keeps different linked lists for different sizes of objects because that's apparently fast or something. I mean, the glibc allocator is not like the best one. Like browsers do not really use that. I mean, or at least not for crucial stuff. So yeah. Any other questions or comments? Okay, thanks.
Thank you. So let's have 3 minutes break. That would be a quick one, just to grab something to drink. I think we'll have around 3 or 4 lightning talks now, so it will take more or less 20 more minutes, and we'll be back in 3 minutes, no more. So that's a very quick break, and let's come and make a setup for the next round of the lightning talks. No. Okay. I think we're ready with the next round of lightning talks. This one would be probably as long as the first round of lightning talks, because we'll have, I think, 4 lightning talks today. So I'm giving the microphone first to Maciej, and this might be a bit longer than 5 minutes, but we agreed not longer than 10 minutes, so there is no need of pointing that he exceeded 5 minutes. Just a warning. Okay, and the scene is yours.
Okay, thanks. So I realized how boring this sounds, vector databases, just now. And I'm sorry, but the topic, at least for me, is quite cool. This talk will be about machine learning and a little bit, maybe perhaps, about security. What are vector databases? First of all, who of you have heard about vector databases? Raise your hand. Not that many people, but some. Okay, so those are some of the projects that are considered vector databases. Some of them are open source. Pinecone is closed source, it's paid service. Milvus is open source, and Weaviate, I think, also, and Chroma as well. I think maybe Milvus is paid, but there are many more even. But mostly they are focused on the text, so like natural language processing, not images. What are vectors in this sense? They are pretty much the same as embeddings. What is embedding in a sense of like machine learning? It's when we take a complicated object and make it into less complicated object, but also we will have a possibility of measuring a difference. Think like hashing, but we can compare 2 hashes together, and hashes of 2 similar objects will also be similar. So other way of thinking is like looking at a shadow. So we have a 3D structure and we are mapping it to 2D, so less dimensions. But if you want a better definition, you really need to dive in to math. Okay. How we achieve embedding in neural networks? When we have some neural network that performs some computation, we take the intermediate layer. If you know neural networks, it's like multiplying matrices, and there are intermediate outputs, and we just can take intermediate output. So it looks like this. So we can just cut a neural network, cut some layers, and get the intermediate output. Instead of having an information, is it a dog or a cat, we can get intermediate output, which is a vector. Let's call it a vector of size 1000. If you have questions, please do interrupt me right away. So what we can do with this? When we have this vector computed, let's say that we have some inputs marked by x1, x2, x3, x4, and we have vectors made from those inputs with the neural network. And we have v1, v2, v3, v4. Those are vectors. So then we can calculate a difference. So we can have a difference between v1 and v2, which is cat and dog, is 1 because it's very different. When we take difference between v1 and v3, which is in essence x1 and x3, which is a cat and a cat, we have very small difference, right? So by those means, we can have something that actually can tell us apart different things. So we can have, for example, a categorization or a classification. In theory, we don't even have to train this network. It can be, in theory, it can be any network. And this is a part of machine learning that is called few-shot learning, because we are not training, we don't need, in theory, to train anything. And to get information that allows us to differentiate between cats and dogs. So why database of vectors? Because computing the forward pass of neural network can be computationally expensive. So instead we can store like labels, we can store images, we can store vectors,
And this is used, for example, for image search. So we can pass an unknown image through neural network, get a vector, and find the most similar vector in our database. Yeah, so out of those, I think that only DeepLake, those are the vector databases, and only DeepLake has a nice user interface and strong support for images. And this is the, let's call it security part. So you can pay attention, Dominik, maybe. So they are giving us an access and as an open source and free, or community which is not paid. And everything inside is here covered by the same repository. And here we have something called access to the optimized compute engine that runs on client. And this is MPL license, so it's free for modification. Okay. I will try to be very fast. Here we will have a very simple example. Let's do it like this. Okay. So very simple example. I'm creating a DeepLake database here. I'm populating it with images. Yes. And here I will perform a search on the database itself. I'm getting an image, I'm creating a vector out of it, and I'm doing a search using that exact vector with the embedding search variable. And this is kind of like SQL, but you can do requests with the vectors. And what will happen? Sorry. What will happen here is we will get an error because this particular database requires us to pass a token, access token, if you are doing computation on your device. It's not externally done, it's on your device. It's requiring access to your own device. And if you will pass a token, of course, it will work. So inside, let's go. So inside, it's if you are doing this, it will actually try to convert your abstract data set to a data set class that comes from the package libdeeplake inside, which is also provided pretty much by the same. It's not provided by the same repository because it would be obvious because the code is inside, but you are installing it sort of by the repository, by the same repository that you install the other code with the pip install deeplake enterprise. So inside, it's using some kind of class and library on your machine, essentially check whether you have provided a token. And if you have provided it, you can go on with the computation. And deeplake is very nice library. The most important part of it is tensor query language that you can ask questions about the vectors. But in order to do that, you still need to validate yourself with a token. The token is validated and confirmed with libdeeplake library. It's all under free license that allows modifications. So modifications to deeplake library are allowed under the terms and conditions. So in theory, I'm not an expert. I'm not an expert in law. But in theory, you could legally modify a libdeeplake library and fix this bug that they have, which I think may pose very interesting challenge to some people because you probably would need then, in theory, decompile this code and find some interesting things inside. And I'm pretty much on the spot with the time. That's it. Thanks.
Okay. Is everyone here speaking Polish or not? You are not speaking Polish. Okay. So I will do the presentation in English then. Okay. So I will talk about the PyCon PL, so PyCon Poland 2023. So it's the 15th edition of the conference. It's one of the oldest PyCons in Europe, and largest stationary Python conference in Poland. So let's start. First, the date and the venue of the conference. So it will happen at the end of June and the beginning of July in Gliwice. So not far away from Krakow. So you can very fast get to the Gliwice using different means of transport. And there are probably the best option is going by train, because there are many trains. Almost everyone going west from Krakow are going through Gliwice. So we will have around 50 talks on the conference on various topics. I think a quarter of them is connected with the data science and machine learning, and others are on topics that are also popular. So, but we still have some free slots. So if you want to become a famous speaker, then you can still submit a proposal through our conference registration system. You just need to set up an account, and you can add there a talk. You cannot add workshops because we already have plenty of them. We'll have 12 workshops on various topics. So 9 of them are in English and 3 of them are in Polish. And I think that most of them are very interesting and on topics that are various. Yeah, we'll have, for example, we'll have from one those workshops. Yeah, they are included in the base price of the ticket. So it's not something you need to buy additionally. You just buy the ticket for the conference and you get that as a part of the ticket. And for example, this one, the 11th, will be conducted by evangelists from Amazon. So the one about the cloud data analytics. So what's next? We have keynote speakers. For now, one is announced because he's already 100% confirmed. So it's a contributor of Fast API and a maintainer of Starlet and UVcorn. And he's also an expert on Pydantic because he works there as a senior software engineer. So it's Marcelo. We'll have also other keynote speakers, but we are, still in the process of getting confirmation, so we cannot announce the other ones. We will have, like every year, some social events. As far as the people that already registered for the conference, they are from these countries, mainly from Poland, of course, but there are also people from other countries. So we'll be conducting a Pylades workshop, but in order to attend in Pylades workshop, you don't need to buy a ticket. But you need to apply on the website, on the Pylades PyCon PL website. And you can do so till the end of this month. So if you know people that do not know Python yet, but would like to start with a Python from complete beginning, then you can recommend applying for attending this workshop. It's a 2-day workshop, and it's on the workshop there will be basics of Python. So Python from beginning, like operating on strings, defining functions, etc. So real basics, and it's a good thing for people that want to start. And we are looking for mentors. If you decide to become a mentor of the workshop, you will get a free accommodation. You will also get free access to the PyCon conference. So you don't need to buy a ticket, you can get a free ticket. But you need to become a mentor. And to do that, you also need to fill a form on the website of the PyLadies at PyCon workshop. There's a form, and you can describe yourself and your experience in Python in order to become mentor at the workshop. What's more? So tickets. So we have 3 kinds of tickets. The first one is the full one, so it gives you the attendance of 4 days. It gives you priority on enrollment for workshops, and it gives you access to the social events. The second one is similar, but you don't have the priority in case of enrollment for workshops. So in other words, if there will be people with the full ticket that will enroll for the workshop, they will have the priority over those with the light ticket. And we will have also an education ticket, but it's only for students that are 26 years old or under. And it's only if you buy those from your own funds, or it's funded by educational institution. So it's basically like the full ticket, but you need to be a student in certain age. Okay. And now the good thing, there will be a discount for the full and light tickets, but it will be till Monday only. So it will be 20%. And in order to get this discount, you need to use this code. And by the way, do you know why this number? So it's the year when, for the first time, Krakow was mentioned on the written paper. It wasn't a city at that time, but already it was existing. So you can write this code. But we also have another discount code that is slower, but there's no deadline, like in the case of the first one. So the first one is 29th of May, and this one is like till the end of the registration. Okay. And if you still think that the prices are too high, and you are very active in a community, so for example, you help on meetups like Pykonik or other workshops, meetups, conferences, or you are a contributor, or you are doing anything for Python community, then you can apply for the financial aid, and you can do it till the end of month. And it basically works like that you write the amount you are able to pay for the conference. So because, for example, the the standard prices are too high, even with the discount. Okay, so that's the website of the event, pl.pykon.org. And I think that's all regarding my lightning talks. If you have any questions regarding PyCon PL or attending PyCon PL, you can catch me in the break or on the Pykonik integration event in Fuzja. Okay, so that's all from me. Thanks.
Hi, my name is Adam. This will be a very short lightning talk. I want only inform you about biggest stationary hackathon in Europe, like says organizers. Organizer is a Kraków company, pro idea. Events will be at the end September and Thursday, October. It's a 2-day event. They will be interested about it. It's an annual event. In this year, organizers won't break Guinness record in number of participation users in stationary hackathon events. It's now is about 3,500 users, like in that. So follow the organization social media profile for free tickets. Thanks.
I wanted to do something basic today. It's not about a competition that we have with Disconnected for more lightning talks, which I can't beat at all today. But at least I thought it would be good to give one lightning talk. And I thought that maybe on top of all of those advanced topics, it would be good to remind about something a little bit more basic, but that's something that I spotted recently when doing some code reviews in my work, that not everyone remembers about that. So I wanted to talk a bit about advantages of not reassigning values in Python. So it's something that builds the efficiency of the code, the clarity, it helps debugging, it's better for the maintenance, it's a good overall best practice. And yes, those slides were AI generated. I didn't know that slides.com have that functionality. But there will be more, no worries. I wanted to get to the real example. So this is the real part of the presentation. I wrote a bit of a code which is ugly intentionally. It is nested, it reassigns the values, it's bad, and it's good because it's simple, but as soon as you would need to find that you need to do something on top of that code, you would find that you're in a nightmare and your tests are breaking and everything is not going into a good direction. And it was probably simple to write it this way because it was a small bit of code and you thought, I'll fit it into one function. It's not a spaghetti code yet. There are only 3 indentations, so should be good. But no, it's not good. It's leading to a mess. And even if that's not a mess now, it will become a mess in the future. So what I like to do and what I like to tell people to do, not that I like to tell people what they should do, but in this case I like, is to first think from the end. So how this function would look like in the perfect world. So if you want to do something like summing account balances, let's say something like that, you should just have a function that gets the amounts from the accounts by the list of accounts and just returns a sum. The code should be simple and readable. But of course, it's missing some information. So for example, it's missing the get amounts from accounts. So a method that was there somewhere in this very nested code. But again, it's an for with an if, indentations are bad, and we're getting into the mess again. So that's where nesting is bad rule comes in. If you cannot nest your code, it's good. So as Zen of Python says, flat is better than nested. As AI said, flat is preferable to nested, or choose flat over nested. There are many versions. You don't be limited by the Zen of Python. Nevertheless, if you can put the conditions on top of the nested, longly nested condition, that's a good attempt. So just try to do a negative condition instead of having a positive one. You can do that like a filtering conditions before you enter the real body of your function. And that's much more readable. In the future, that would save you some time. It's still missing something. It's missing the list of accounts. That was the code that I used earlier. And my goal for that was to squeeze into this box that I filled in previously. I'm not squeezing into this box because the balance is not filling in. So it's bad. We can't have it this way. And additionally, we can't have it this way because we're having accounts. We're assigning accounts from different sources, then appending that to a list. If now you would like to attach MyPy to that, it would be a mess, and probably it would get to the mess. So what can you do? Just use a flat condition where you try to get the account from backend first. If that exists with a nice walrus operator, just return that account. You can also try to get that from the external system and just return that account. But then still there is this big for with an if, with ugly stuff. So that's where built-in Pythons come handy. You can always filter by none, so just to filter out the non-values from a given list, and you can just map the account list, map the accounts from IDs from the account IDs list. So that's it. 4 functions, everyone separate. Why it's better? Let's take a look at what we've had before. It's shorter, yes, I agree. But if we would like to now write some test cases for that example, so for example, test sum account balance view if no accounts, easy. Then if the accounts are coming from backend or the external system, or if the backend fails, or if the external system fails, or if there are no debit values, or there are debit end values, or it doesn't even squeeze into the screen anymore. It's a mess again. With this approach, you have 4 methods which have single responsibility, which are easy to test. You can test the get amount from account if there is no debit, if debit has no value, if there is a debit end value. You can test getting from backend, from the external system, test when user not found. It's much more readable and would make your life in the future easier. If not yours, someone else would take a look at your code. So that's it. I asked Slides to generate a thank you page, and I think that it did a great job because it also put this lovely slide here. Thank you. And we're also going to do a quick outro of the meeting today. I wanted to once again thank all of the sponsors. So once again, thanks SpotOn for a lovely venue, pizza, and drinks. Thanks JetBrains for 2 PyCharm licenses that we would give away in a minute. And thanks Kluk for having the stream online. And that's also the point where I would be saying goodbye to everyone who was watching us online, because the next part would be here offline only. So So thanks to everyone who was watching us. And where to find us? Oh, that was the one more that I wanted to include in the streaming, but never mind. Pykonik.org, Discord Pykonik.org. We're also on Meetup. We post the information on Facebook if you prefer that. But nevertheless, these are the main sources of all of the information that we tell about Pykonik meetings. And about the competition, I've seen a few messages on the Pykonik 64 channel. And I'm opening that right now. And I see that the most reactions was under Maciej's comment about format being slower than F-string. Maciej, do you want a PyCharm license? All right, so we have the first one. And there was another one that was not from the organizer. And I see that someone is liking posts right now. PBEDN. Do we have PBEDN here? Yes, do you want a PyCharm license? You got no, yeah, you have one like under your comment now. Easy earned. Okay, so I will ask two of you to come here and leave me your email addresses and I will send the licenses to you later on. And now we're heading for the after party. We will do it in a way that I will be raising my hand in 2 minutes from now, more or less, and I will be guiding to Infusia. So who is coming with me? Nice, that's a nice score. So I will be guiding you to Infusia in 2 minutes. I will announce it loudly. I will try to shout a bit, but not too high. And we don't need to clean the space. Kinda need or kinda don't need? We do. Okay, so we will need some volunteers to help with clearing up the chairs, but Piotr would be here to guide you with this. And thanks for attending Pykonik 64. Thank you.